description. My name is Vittorio Bertocci. I am a technical evangelist on the Windows Azure evangelism team, and my focus is on, you may guess it, identity and access control. I'm a very boring person. I like these low-level details. And today, I'm going to try to make you like that as well. Actually, no, I'll do the opposite. Because today, if that would be, how to say, acceptable for my position, I would be yelling, this is Sparta. I don't know how many of you guys came into my sessions, these TechEd or the former ones, but usually I try to be like the inspirational guy. That's to say that things that you more or less already know, and I try to help you to connect the dots in a certain way, so understand the whys and similar. Well, today, no. Today is Sparta. That's to say that if you want inspiration, you have to bring it yourself from outside the room, because today I'm going to do training. This session is a deep dive about the Windows Identity Foundation, which, by the way, is a developer product. How many of you guys are developers? Thank you, thank you, thank you so much for being here. Where were you yesterday? Like in my other sessions, but who's developer? Small percentage. Well, that's good, because this stuff is all going to be purely for developers. So my goal today is to help you understand what makes Windows Identity Foundation tick. This is a deep dive. This is a 300, so I'm not going to pull out of the compiler. But still, it's a deep dive. So I assume that you guys are interested in understanding how this stuff works. Also, in the process, we will understand what are the key components of Windows Identity Foundation, the role that they play in the classic default flows, so that you know when you want to change the default behavior, which in at least the 20% of the cases you will, because like the default is just like a plain vanilla application, source, I authenticate. It's almost never exactly what you want. We will understand where are the pull knobs and levers that you can go and modify. And it's going to be interesting. I've been doing last year these 2 days classes on Windows Identity Foundation around the planet. It was fun. I did a lot of miles. Now I'm diamond with Delta thanks to that. And I have some experience with how this content is received. Like, of course, I could not condense 2 days in 1 hour and 15 minutes. That would be asking you too much. But here I'm putting like the most intense part of the class. And if you invest the energy to follow the key parts, then you enter that you knew more or less what the WF was, and you leave the room and you know what happens. And it's really useful, because once you understand how it works, then it is obvious where to change things. You may not know the syntax of how to do a certain thing, but at least you know if it's possible, how it's done, and so on. But it requires you a lot of effort. So just so we are clear, if you're tired, if you never heard about WF, if you don't like my accent or my long face, then, hey, there are many, many, many other sessions that you can take advantage of. You spend good money for coming here, so. And here, that would be the right moment for asking my customary question. Am I talking too fast? No. Ah, excellent, great, thank you. So I'll assume it's okay, and I'll keep talking like that. Non-goals. I will not introduce what is claims-based identity. Yes. How many of you guys know what is claims-based identity? Most of you guys. Right. For the other ones, I'm very sorry. Perhaps you will pick it up from the context, but we have so much stuff to cover that I'll skip that part. Then I will not discuss high-level scenarios. Of course, they'll come out in the discussion here and there, but that's not the main goal. Here, the main goal is literally to put our latex gloves on and shove our hands in how it works. And then, again, not about the whys. I assume that you already have good motivations for using these. Otherwise, you would not have ended up in a room which says deep dive. Do we have a deal? Excellent. Good. Windows Identity Foundation. By the way, then, the thing that you have seen on the screen before, It was what you find in Amazon when you search for Windows Identity Foundation. You find the books, but you also find the foundation, as in the thing that you put on. So I thought it was nice to put it on. It is a part of the .NET framework, even if it doesn't ship inside the .NET framework. There are good reasons for which it doesn't. I'll tell you later what those are. Same licensing. Let's say that it is free. I like you guys. You are very interactive. Thank you. We shipped this guy in 2009, so don't think that this is, oh, wow, beta, cutting edge, I'll eventually think about it. This is out in production, and there are products taking a dependency on that. SharePoint 2010 ships with the WF DLL. DLL, which we call the WF runtime. The WF runtime is substantially few DLLs which implement the nécessaire for using claims. That's pretty much it. It's just the set of classes that you use for that. And then there is the SDK. Actually, we have two SDKs. One for .NET 3.5, Visual Studio 2008, and one for 4.0 and Visual Studio 2010. And they contain the same stuff, simply adapted for one case or for the other. And they also contain samples, and they contain the tools, but actually one tool, which you can use for simplifying a lot of these interactions. So what does it do? Why do we use this thing? WF is middleware. Middleware which sits in front of your application, be it a website, set of pages, be it a web service, something that you call programmatically, so without a browser. And it intercepts requests. And once it intercepts the request, what does it do? It enforces one authentication protocol. So imagine, like, how many of you guys are familiar with Windows Forms? How about web forms? Good, it was web forms. Windows Forms just sounded better somehow. So there, you just have this redirect which send you to the login page using this infrastructural trick. Here, WF does the same at a higher level of abstraction. If a user comes in and is not authenticated, WF will do something, will enforce one protocol, be it one which comes out of the box or one that you added later, and it will let this thing pass only when it is satisfied that the user authenticated. Once we are done, we surface claims to the application. And the entire idea is that we add this level of decoupling so that you don't have to change anything in your code if you change something in your deployment. Noble goal, doesn't always work, but that's the intention. That's more or less how it usually works. So what makes this interesting? Well, of course, this first part is very interesting as well. Let's say that in the basic case, you get out of the entire authentication business. You outsource that. You protect your application developer from knowing the details. But if you really want to actually know about the details, at least WF offers you a structured approach to that. Let's say that it surfaces hooks in the correct places so that you don't have to litter your code, your application, with authentication or authorization code. In fact, usually, all the code that you write lives in the WF pipeline. So you keep not touching your application. But you are required to understand more of how that works. Classes in the WF framework can be used for also other tasks than the flow that I described there. For example, how many of you guys know what is ADFS? Everybody. Well, you probably also know that the ADFS is built on top of Windows Identity Foundation. And in fact, the Windows Identity Foundation contains classes also for implementing STSs. This is one of the things in which I should have subtitles. Professional driver on a closer course, do not attempt, or do not try this at home, all these kind of things. Writing an STS is deceivingly simple. It's very simple to write it, but then what you get is not an STS. It's something which uses the protocol, gives you a token, but when you put it in production, so once we'll get to the proper part of the presentation, I'll repeat the warning, but I just want to make sure that I say it every time. Otherwise, back in Redmond, they tell me, you promote writing your own STS. And they try to cut my hair. We don't want that. My wife would be very, very sad. All righty. How many of you guys ever used iPrincipal? With this rolling R, of course, everybody. iPrincipal is the trick that the ancients, the original designers of the .NET framework, devised for managing identity in .NET applications. And the idea is that we have this generic interface, which more or less describes what should happen for one identity. So here, I don't know if you can see, but probably yes. You have this iPrincipal, which lives in every thread. In there, you have this isenrole, which you can call for using role-based authentication. You have this iIdentity, which substantially tells you if the user, the current thread, is for an authenticated user and similar. And the idea was that every time you add something which is not a Windows principal or a membership principal or similar, what you do is substantially, let me change color, is to write your own derivation of iPrincipal, in which, for example, you have your own custom credential type, and then I'll do my iCoconut principal. And here I will just add whatever I need. And then the issue here is that everybody would do the same. So you have to first change these in your own code. Let's say that you, as the application developer, you have to write a different class. You have to make a different include. And also, at this point, you have to make a choice. Since we don't have a multiple inheritance, if you want to use one system, you use one. If you use another, you use another. Since identity is everywhere, you'd have a switch in cases which litter your code all over the place. So better than nothing, but hey, not exceptional. So for solving these, guess what we did? Well, we did exactly what I'm telling you not to do. We derived from iPrincipal, but with the hope that this is the very last time that this has to happen. We derived from iPrincipal with this iClaims principle, which substantially has all the same things that you had before, and on top of that, it has also a set of claims, actually multiple set of claims, although the vast majority of cases is just one. And the idea is that this trick allows us to be also in code which already exists. If you already wrote your code, which is using iPrincipal, is using isenrole, is using the authorize element in the config, we just work. As long as you have a mapping between this type of claim is a role, you should consider that a role, then everything works. But at the same time, for the fact that we are using the claims here, we are decoupled from the details. That's to say that which credential are we using, which protocols are we using, this all takes place outside of your code. So this iClaims principle remains the same regardless of from where I'm getting this identity. Am I getting it from a X509? Am I getting it from a SAML token? Am I getting it from Kerberos? I don't care, because as application developer, all I care about are the user elements, not how these took place. And then, of course, this is the principle. I don't know why PowerPoint is not answering. Of course, I went too far. Come on, I am your master. Obey me. Somehow I failed the charisma check. You know what, let me do ask. I hope that all of you guys, being geeks, played Dungeons & Dragons in a certain part of your career. See, it's back. Great. So we have iClaims principle, we have iClaims identity, which is one single part, which of course contains a set of claims, and also contains a lot of other interesting things, which I'm not going to touch in here because we just have 1 hour and 15 minutes. So for example, we have a delegate which may contain other iClaims identity if you are acting on behalf of others. And a claim is pretty uninteresting. It's simply something which says, I am referring to this identity, basically a pointer to the main identity, contains from where that specific claims is coming from, since you may have claims from different sources, contains from where it came originally, since you may have transformed it in many steps. It contains type, values, and similar. And from the application development perspective, all you need to know about these is potentially nothing. That's to say that if you don't care about the user attributes, you don't need to access this thing. As long as you use the tooling for configuring your app to use WF, you don't need to know any more details. But if you really need to do something in your application about identity, then you have this model, which is completely decoupled from what happened. Once you get at this point in which you grab all those elements from the current thread, authentication already happened, and the details of how that happened are left behind. So if I take this application and I deploy it internally, and I use Kerberos, then the marketing guy from Microsoft comes and convinces me that Windows Azure is the next best thing after, I can't say what, because I like to be employed. Then you can take exactly this, deploy it in Windows Azure, use a different system, because unless you use Windows Azure Connect, you will not have a Kerberos in there. And this code doesn't change of a comma. It remains exactly the same. And how many of you guys use Link? Yeah, look at that. Once you have this collection, you can do whatever you want with that, including querying it like this. In this case, I'm just pulling out this custom claim, but usually you get a list of specific attributes which are useful in standard situation, from the role to the name to the email for notifications and similar. And you can do interesting things, because in classic roles-based authentication, the only check you can do is, are you in or are you out? Here, instead, I can find out where you were born, or how old are you, or what is your spending limit, or I don't know, any structured information, not just a membership check, but anything, including, if I want, structured things. Like I could serialize one object into a string, and then as long as I have a value on the other side, deserialize it and have it in my context, which is pretty nice. And before going much further, at least I have to show you the basics. So what should we do? Should I use an existing one, or should I create a new one? Let's create a new one. So here I'm creating one new Windows Azure project. How many of you guys ever created a Windows Azure project? It's a thrilling experience, so you should absolutely give it a try. In fact, look how excited I am. I clicked OK. So here, in all seriousness, all I'm creating is a web application. What we call a web role is just a web application, which happens to have all the necessary information in this other project for telling Windows Azure how to run it, how many instances you have, which parts you want to open, if you want to use SSL, and similar. So to all practical means, this is a website. And it would work exactly in the way in which I'm showing, even if I would be using a website on premise. So let me open a simulator of STS. Of course, all of you guys know what an STS is, right? Can I see hands? Excellent. OK. So here I have this little utility which pretends to be one STS. Actually, it is an STS. Very, very simple. Completely unsecure. Don't use it unless you're testing. And here, the entire trick of Windows Identity Foundation, and I'm sure that you already know, is, oops, let me first run it because I need the part which is running. The entire trick is I run this little wizard, and this wizard will read the details of STS, will use those details for automatically generating a web config on my application, and that web config there will be all the necessary info for knowing which protocol I'm using, which identity provider I'm referring to, how to contact it, and so on. Oh, great. Strange. This shouldn't have happened. It seems that my IIS is down. Oh, that's fine. OK. So let's add the STS reference. And so what I have to provide is the URI of my application, which is not an HTTPS, the address of the metadata describing my service. Here it is. here I get the list of claims that I can get about the user. Very straightforward. I'm not spending any time on this. And then, for now, we have a little bug in the tooling, which forgets to add a validator in your web config. In 4.0, you need a validator. So I need to tell it to use the old style, otherwise it will crash. But we have an update to the tooling coming very soon, so you should not be forced to do this anymore. So HTTP runtime, request validation mode 2.0. OK. If now I hit F5, my system will pull out our Dev Fabric. Oh, sorry, Windows Azure simulation environment. I'm sorry? Windows Azure emulator environment. And here I froze the time for a moment just for showing you what's happening here. I tried to get to 127.0.0.1, which is where my application lives. WF found what I was trying to do, blocked me, and redirected me to the identity provider, which is here. The identity provider is a test, so it's not really authenticating me. It's just giving me a token. And so now, ta-da, here we are. I am Joe, and I'm authenticated. Very, very easy, very straightforward. Whoops. That's the super basic part, is using the tooling. This has got to be enough to most people, which sounds like the famous sentence, 64K ought to be enough for everybody. But in this case, it's true. Let's just say that it's 5 years that I play with this stuff, and I can tell you the vast majority of cases, that's it. People don't want to savior the authentication experience. They want to get it out of the way. And in this way, you do it. You don't need to know anything anymore. So that's the basic way. The other way of interacting with WF is to change the configuration settings. Identity has always traditionally been an IT pro affair, something which the infrastructure guys do, something which takes place at deployment time. So WF tries as much as possible to do everything in configuration, so that you can pretty much change anything without asking the dev to go back and recompile, which is great because less annoyances for us. We are also relinquishing a bit of control, but that's good from time to time to do that. And then the other way is to actually get specific classes which are not specific to the protocol, like you don't need to know which protocol WF is using for this, but you can derive from those classes, we'll see in a moment what they are, so that you can influence the behavior of WF. And those classes will work regardless of the protocol that you use. And if you go deeper, here you can write handlers. They can actually start writing specific code in which you serve events that WF raise at key points in the pipeline while processing the request. And we'll see those in painstakingly low details. Prepare yourself. Actually, I'll prepare myself. Red Bull. And then finally, you can create classes which are protocol specific, for example, token handlers. And then at that point, you can use the config for adding them. And now, here we can put this imaginary line. You can think of this as water. And on the surface of the water, you don't need to be a big expert. You need to know more or less how this stuff works, but you can get away with it. And below, instead, there would be dragons. This is just for scaring you a bit. Meaning that as soon as you get under the surface, then you've got to understand how the protocol works. Because otherwise, you will not know where to put your hands or what is the function of these various elements. And this is basically me apologizing for the fact that today we'll actually go at the protocol level, which is usually something that I try to avoid. That said, the config. Let me go back to Visual Studio for a moment. The effect of launching that wizard was substantially to add this element to the config, this Microsoft Identity Model. Then there are other effects, like, for example, we added a config section which says, hey, ASP.NET, expect this thing there. We added, of course, the assembly, which is the runtime, which is here. And then here there are a set of modules which make the bidding of the BIF, and which we will analyze in detail in a moment. And if you look at what's inside this guy, you'll see most of the things that you can change of the BIF. So here I'm showing all the elements that you can find in there from the easiest to the most advanced. So the first element is this service name. This service name describes one set of settings for the BIF. You can have more than one. For example, when you deploy things in Windows Azure, you can deploy to multiple environments, like the staging, the production, and perhaps you also want a section for your simulation environment. So this element allows you to group things so that you can switch then at runtime between one and the other. Then we have one section, which is federated authentication, which substantially drives the main back and forth, the main forwards. And here we have one element, which is WS Federation, which is specific to this protocol. If you'd be using a different protocol, you'd use another. And then we have the cookie handler, which is instead where you hook the management of the application. I warned you guys that this was going to be tough. Then you have these audience URIs, which are substantially the list of values that you are willing to accept. So think of tokens as bank checks that are written for somebody. Here you are telling to the BIF basically who are you, meaning, hey, I am a Vittorio, so accept checks only for Vittorio. If they are for James, well, I'm happy for James, but refuse them. And here basically is the same, but for your application. Then this thing you can ignore. And instead, for the issuer name registry, here you put the list of the identity providers that you trust. That's to say that you won't accept checks from any bank, but only from specific banks that you are OK with. For example, here you may accept only checks from US banks. And here, substantially, you just have the list of all the various identity providers in terms of their certificates. Here you keep the thumbprints of the certificates that are used for signing the tokens. And all this stuff is already automatically generated for you by the tooling. And in fact, here we can take a look. Is it big enough, or do you want me to zoom further? Good, excellent. You know, I kind of knew that, but I like to know that the audience is alive, and you were scarily silent, so I had to break the ice somehow. So here you see this audience URI element, which substantially is saying, hey, I am 127001. So if you get a token from somebody else, we are not friends anymore. Then in the federated authentication, we have the cookie handler, which in this case is just saying, I'm not using SSL. I could enforce SSL. And you can tell a number of other things, which I'm not going to bore you with now. The WS Federation is the one which is most interesting. Here we are saying things like, we want a blanket protection. That's to say that as soon as somebody hits the website and they're not authenticated, we'll throw them to authenticate. Here we are saying this is the address of the authority that we want to stick with, which is this guy. Then here there's the realm, which is myself. Let's say once the user is done authenticating, send them back here, which in fact is not completely true, but it's a good simplification. And here again, they require HTTPS. Then the application service, we said that we can ignore. The issuer name registry here, as you can see, has just one trusted issuer, which is the issuer which I'm using here, the one that I've just shown. And here I could have, of course, a list if I'm trusting more than one, or if I'm trusting different ones in different environments, I could list them all. Also, in this case, I'm using this class. Here you can already see some extensibility for describing the issuers. There are different ways of doing that. For example, if I'd be trusting an issuer from OAuth, I don't know if you get my pronunciation, How many of you guys know what off is? Off? Let me be super explicit about this. Control 1. I know that my accent is horrible, and I apologize for that. Ah, come on. I was expecting seeing, yeah, did he really say that? Yes, I said that. Well, if you use a provider which comes from off, as of today, they are not using certificates. So no thumbprint for you. They use symmetric keys or like these interestingly weak systems. But I know that asymmetric keys are coming. But anyway, if you do want to add an off provider in there, you'd have to write your own class which identifies that issuer not using the thumbprint but something else. And again, we'll see this thing in details. And then that's it. So let me come back in here. So that's pretty much what the configuration does. And here, as you can see, you can get away without knowing much about the protocol. Because like if you ignore the WS federation, which more or less, that's it, yeah, you can change to things like I want HTTPS rather than not and similar. So no rocket science yet. The next one still does not require rocket science. The Claims Authentication Manager is one class that you can use for doing some claims processing before the claims reach your application. That's the place where you would do things like verifying if an incoming user belongs to a database that you already have. Like if a user already signed up, you just wanted to make the check. That's the place where you would do it. And if it isn't, it's the place where you can say, hey, stop everything, I don't know this guy. Or it's the place where if you have profile of information that you are not getting from the identity provider, you can actually add it to the incoming claims so that your application developer doesn't have to go to a token or to a store. It can always use the same interface, the claims, and similar things. For these, you don't need to know the protocol because the implementation of this guy gets iClaims principal in, iClaims principal out. So I don't need to know anything about SAML, X509, WS Federation, and similar. The same goes for the next one, Claims Authorization Manager. Who is so bold to try to guess what this thing would do? Authorize, excellent. If I'd have a prize, it would be yours. So this guy does exactly the same thing. Let's say that it looks at the set of incoming claims, and here is the place where you can enforce things. Like if you want to use something more advanced than the simple is enroll, and you want to do something like, I don't know, if this guy is younger than 21, don't show that image, because it's about elections and they can't vote yet. Got you? Always works. But anyway, here, that's the place where you can enforce your custom authorization logic, and you have like a complete freedom. You can literally do whatever. And so far, still no knowledge of the protocol required. However, once we get in here, have purple stuff. When you get in here, then you start talking about the protocol. The security token handlers are a collection of classes that are used for processing specific token formats. So when WF sees a SAML 1.1 show up at its door, it goes in the room of the token handlers and asks, hey, SAML 1.1, and somebody picks up and says, yeah, that's me, walks in there and starts deserializing that specific format and do whatever the SAML 1.1 token format requires. Same goes when an X509 comes in, which happens all the time because when a token is signed, it is signed with an X509. So for checking the signature, you need to deserialize in memory an X509 so that you can do the signature. And so, again, WF will see this X509, go back to this room and say, hey, X509, and then a token handler will stand up, show up, and do its dirty job. And here you have one specific area of configuration which somehow repeats the config that you see outside. We don't have time to discuss why that does it. If you are interested, this evening we can have a beer somewhere, and I can tell you the story behind this. And here you can literally use this as a classic ASP.NET collection. You can add, you can replace, you can remove token handlers from your collection. And here we start to get into the deep. By default, you have a number of these, oops.
Yeah, I just had a quick question. Kind of what you were saying. Which of these would we get in trouble in the next release that they might get broken? Which of these are solid that we can use? You know what I'm saying? Like, which is documented, or is some of this stuff undocumented? We're going to get in trouble if we use some of these levels that you're talking about.
So for once, I don't have to repeat the question. Thank you for using the mic so nicely. Well, I don't think there is any of those for which you will get in trouble for. Then, of course, I cannot promise anything because, one, I'm not in the product team, so I can't take things on their behalf. I can certainly bring them feedback, though. And second, even if I'd be in the product team, until you don't have the next release, we can't say anything. Like, you may discover something which forces you to change the model. But let's say that to the best of my knowledge, all of this stuff is there. Let's say that, yeah, you may see changes here and there in terms of pure syntactic sugar. Like, for example, if we observe that people always do a certain level of indirection, we may put it in the object model instead of asking everybody to always do it all the time. But the concepts and the pipeline and the infrastructure, it's pretty much there. And again, there are products like SharePoint 2010, which take a very strong dependency on this. Let's say that they heavily customize the pipeline and similar. If we change it, then they'd have a ripple of change there as well. So I'm not saying change cannot happen, but I'd say this stuff is pretty solid at this point.
Okay, thank you.
You're very welcome. And so here, for example, you have a set of handler elements where you can actually tweak things back and forth. Like, for example, in the SAML security token requirement, a config element, you can tell to the system which claim type you want to be the role for ASP.NET. That's a place where you can tweak that. Or you can change the way in which you handle the session. This is a very, very, very important handler. Because for the session, it's the place where you make these network load balanced aware, or if you want to do sliding sessions, like if a user is active for 5 minutes, then renew, otherwise expire, even if a token had a longer expiration. So that's an important place. And of course, you can add your own. So for example, again, I come back to the OAuth sample. We wrote an extension for OAuth. We had to write our own custom handler, and it ended up in there. Again, potentially you can have one service which was using WS Trust or the WCF in general, and you can take that, move it to use OAuth, and change nothing of a service. Just change this config in front of it, which I rate pretty awesome. Alrighty, so that was the base. This holds both for ASP.NET and WCF, with exception of this little guy. WS Federation is just for ASP.NET. Instead, WCF, of course, has to do its own thing in the bindings, but the rest of the configuration is exactly the same. Like the security token handlers will work in either cases. So now, let's talk a bit about ASP.NET.
Are you interacting with the actual tokens at that point?
I'm sorry, I can't hear you.
Are you interacting with the actual tokens in those places, or are you just providing information that gets included in the tokens? Does that make sense?
I am not sure I follow.
So the issue tokens that I assume are flowing through this pipeline, in these token requirements, are you interacting or modifying the actual token, or are you just providing information that gets included in the token?
So in here, we are not in the pipeline yet. Those are all the elements that we are adding for influencing how the pipeline will behave. Those classes are the classes that know about the implementation details of a token. Let's say that, as we'll see, the pipeline is generic, but when you instantiate it to serve one real, actual request that you're getting, you need to go into the details. Those classes are the ones that have the knowledge about those details. So you may say in the pipeline, at this point, I need somebody who will deserialize the token, check the signature, and tell me if it's not expired. Those elements are the ones that know how to do that for SAML, another knows how to do it for OAuth, and so on. So they interact as in deserialize, extract info, validate info, but and we are not there yet. Like here is just the place in which you say, I want these in my team. Perfect. So basically, in a nutshell, at the end of the day, for ASP.NET, we just give you a bunch of HTTP modules. How many of you guys know what an HTTP module is? Great. For everybody else, you will soon enough. What do we do here? We enforce the protocol, as we said. We manage the session, as in once you have done with your authentication, I don't ask you to do it every time. I will manage the session somehow. And also, we use it for authorization. There are others, but they are minor, so I don't want to concern you with that. Out of the box, we use WS Federation. That's a nice protocol. I personally like it. Like, I won't say if it's better or worse than SAML protocol, but it works. And anyway, you can rip and replace. Let's say that we have all these modules precisely so that you can pull out the one that you don't like and put the one that you like. And in fact, just a couple of days ago, we announced that we have extensions for using WF with the SAML protocol. How many of you guys know the difference between SAML protocol and SAML token? 1, 2, kind of. OK, in a moment. WS Federation. It is an OSIS standard, and it's been out for a long time. And most of the single sign-on products out there support it. And even if they open by saying, oh, we do SAML-P, ask them, go and search on their website, because usually they also have this little checkbox, use WS Federation. And mysteriously, since we shipped ADFS2, all of a sudden everybody is starting to also say that. But who am I to judge? Then, basically, what is this protocol? It's simply a list of recipes for telling you how to ask for tokens, how to transmit the tokens to the one who needs it, how to renew them, how to clean a session for doing a single sign-out, and so on. So, standard protocol. Very often, people say WS Federation, and they mean the passive case, that's to say, using the browser. In reality, the standard is bigger. That's to say that WS Federation describes, in general, when we have more than one entity, how those entities should talk to each other. And if that's at high level, it works also for web services. Then it has another part which describes a binding with the browser, and that's what usually people think. So just so that when you search the literature, you know how to read it. WS Federation is token agnostic. I can use whatever token I like as a format. And usually we use SAML. We use SAML because it's super expressive. It's really, really powerful. So we like it. We use it, the SAML format. But we are not forced to. For example, how many of you guys were at the keynote day one? Right. You see the little thing with a phone that authenticates you using LiveID, ADFS, and these things. See, that's our stuff. That's pretty cool. And that scenario is enabled exactly thanks to this. Because when you get all those identity providers and you click one, you interact with that using a little browser inside your app, and you are using WS Federation. But the token that you are getting is not a SAML token. It is a lighter format that you can later use from the phone for doing REST calls. This is something that you would not be able to do with the SAML protocol. The SAML specification is something which describes both a token format, the one that we also use in WS Federation, and an entire protocol. That's to say, it has its own way of asking for tokens, sending tokens, renewing tokens, doing single sign-out. It is a different protocol, even if very similar. And the main difference is that one, that it is stuck with a SAML format, which is great for the vast majority of web single sign-on cases, but is not specific. Like it cannot use any other format. And just to see how this works, if I would have captured the back and forth that I did before, we would see the following. And I promise this is the only swim lane diagram in the entire presentation. Here you have your browser, and here you have your page. And you start by doing a get. I want this page, and I'm not authenticated. So WF is configured so that it tells you, OK, if you want to get here, you have to go to this other location, where the location is the address of identity provider. And then it passes a few variables that are described in the WS Federation. And I'm inflicting these upon you because it's useful later for the configuration, in which I tell you what is the action. I'm doing this because I want the user to sign in. I could do sign out, for example. What is the realm? Here, that's me. This is the address for which the token should be issued. And then the time and various addresses that I'm not showing. So now the browser, which is not well known for its brilliance, it just renders whatever it receives. So it honors the 302 and does a get of that address using all those parameters to the identity provider. The identity provider does whatever it thinks it's appropriate for authenticating the user. In our sample, nothing. But in real life, you'd have, for example, Kerberos, if you are sitting in front of your PC in your network. Or you could have a username and password if you are trying to do that from outside your network. Whatever system your administrator is excited about. And once this works out, you get back the following. You get a 200, and you also get a form, a self-posting form, which contains things for the website. This is a message from the identity provider to the website. And the key part is, here I'm saying, this is a part of a sign-in that you asked me to do. And here, there is the token that you asked for. This W result is a variable which contains the token. At this point, the browser dutifully executes the form and hence sends the post. And here, WF verifies that the token is good, and here, apparently it is. So it sends another redirect, but this time on itself. On itself because it wants to set a session cookie. So that the next time that you'll come, like you'll follow the 302 by sending again the 200 in the same place, but you will also send this cookie. And here it is. At this point, that cookie contains the information that the system needs, potentially no longer the token. That's to say that I may save only the things that I need to remember. I may even save just a reference to state that I'm keeping on the server. I don't need to send the entire thing all the time. And finally, few milliseconds later, even if it's looked longer, you get back at 200 and the page you were asking for. And from now on, as long as you send that cookie, and as long as that cookie is valid, then you will not need to go back to the identity provider. Is that hard? Let me ask again, is that hard? No. Again, I apologize for my horrible, horrible diction. Good, that was the easy part. Now, let's go on the next 3 slides. If you have a few energy left, spend it all now and then feel free to ignore me after that. But the next 3 slides are why you paid the money for showing up. So if you are distracted, you are basically losing your money. Psychology. So this is a representation of a set of events which take place when ASP.NET processes a request. You have an ASP.NET application, you receive a web request. There are a number of events which take place that ASP.NET raises so that if you write an HTTP module and you subscribe to one specific event, then you can serve that event. And there's way more than those, but those are the ones that we are interested into when we do authentication. They are authenticated request, something just after that, authorized request, and the very end of the pipeline. WS Federation Authentication module quite a mouthful, is the class that takes care of enforcing WS Federation Protocol. It is one HTTP module, and as you can see from those insightful, swelling things, that's the set of events that it serves. And it's what enforces the protocol. Then we have a session authentication module, which is the thing which takes care of handling the cookie. And it lives just after in the pipeline. In fact, it should be independent that you have before or after, but usually it's after. And then finally, you have a claims authorization module, which is a module which lives pretty much at the end of the pipeline, and it is the part that enforces authorization, if present. Like usually, you see always the first two, usually always, you always see the first two, and sometimes you see the third. Like the third, if you want to use it in role, is not necessary, but still. So let's see what happens when we receive an unauthenticated request. And let's change color again. Actually, here there is another guy that we have to add, which is the URL authorization module. I didn't add it because that's ASP.NET. That's not WF. Those classes are WF. OK, so let's say that here you have your guy, browser, and a lot of hopes of getting a page. So here you send your request. Send your request, and ASP.NET instantiates the pipeline and calls all of the modules which subscribe to authenticate request. So we arrive here, and the implementation of WS-FAM here is I look at the request. I search for a W result, the thing which contains the token from the browser, which we have seen in the swim lane diagram. If I don't find it, well, you know, I really don't care about this request. So I do nothing, and I just pass it through. The next one, like ASP.NET calls the next module which subscribes to authenticate request, and that's the session authentication module. Here, the session authentication module looks at the request and searches for the federation cookie. But we are not authenticated, it's not there, so I do nothing. And like I step out and I let the ball run forward. And it goes forward. So once I'm done with authenticate request, I raise the post-authenticate request, and I get in here. Here, my implementation looks at the request and at the thread, and wonders, is the current principle an iClaims principle? Because if that module is in the pipeline, then I want to guarantee that the process, the application, will get an iClaims principle and not a principle. And if it isn't, then it will copy whatever is in there and generate an iClaims principle which wraps whatever info I have in there. So I come out of this event having one iClaims principle in my thread. Are you with me? That's still pretty easy. It will get worse. Once I get the sum here, the session authentication module, I do exactly the same, and I mean it. It's exactly the same code. I look at the request, and if it's not an iClaims principle, I create it. The reason is because those could be in different order, or I may not be using the FAM, I may be using another module. So somebody got to do it. But in this case, it's already done, so doesn't care. And so goes straight. Finally, we arrive here at the URL authorization module. And since when you run the wizard, you actually change the authorization in which you do deny question mark, let's say deny everybody but the authenticated one, here this guy says, I'm sorry, but you're not authorized. So call send request aborts the thing, and basically you get back here to end request. Now, the implementation of end request in the FAM is, I look if I'm just about to send a 401, which is the case here, and says, wait a minute, maybe it's not that I want to refuse this guy, maybe I just need to send him to authenticate. And so it goes in the web config, searches for the identity model element, and if it finds it, then it uses it for building a request for a identity provider, and then here, very important, I said the very important. Very important? Yes. Here, it raises one event, which is redirecting to the identity provider. It warns the developer saying, hey, I'm just about to redirect to the identity provider. Do you want me to tell it something on your behalf? Or maybe you want me to send it to somewhere else, because sometimes you want to override the config. And here, after served this event, it actually sends it back to the identity provider. Now, what happens to the identity provider? We don't care. What we care about is that finally, eventually, something will come back, and it will have the token that we need. So now there are so many things which take place in the authenticate request of the FAM, which I'm going to use the entire slide just for that. So the other modules are still there, but they are outside of the slide. So now we are in the case in which we receive the request, we search for the W result, and we find it. And so we trigger all our flow. So first thing, we need to extract the security token out of it. And here is the moment in which we call for the security token handler. We look at the format of the token, and out of that we derive which handler should be used, and we pull it out. And here we decrypt the token if it's encrypted. We deserialize it, of course. Let's say that we have a format which makes sense in memory, and we'll use it. And we check if it's signed. So before everything else, all these things need to take place. In order to do that, I needed to use other classes. Classes such as, for example, the security token resolver. This thing is what gets a token and gives you back a cryptographic key. So if you look in the pipeline, when you want to check a signature or when you want to decrypt stuff, in the end, you need to get to one string which contains that key. And this thing is not always trivial to do. That's to say that sometimes your certificates are in your certificate store. Some other times you keep them in memory. Some other time they are on the file system. Some other time it's not a certificate at all. It's just a key which you are keeping somewhere else. So the security token resolver is what it is used for getting the key for checking signature for the identity provider and your own key for decrypting. If you think that I'm going too deep, I am not. That's to say that if you want to write your own implementation of auth, those are things that you need to know. So let's say that everything we have done was actually successful, and we managed to deserialize the token. At this point in memory, we have a token. Good. So we take this token, and we do further processing. We want to authenticate it. Now we just looked at it was well-formed. It was well-formed. For the validation, we need to do things like checking that it contains the right set of claims. In this case, we check that it's coming from the right place. So far, we checked that the signature was good. Let's say that nobody changed it in transit. But now we want also to know that it was among the ones that we trust. So that's where we go for the issuer token registry, and we see if the thumbprint used is one that we trust. And that's great. I have no idea why my PowerPoint is so sluggishly slow. What we get at this point is the set of claims that we extracted, and here we call the first green class that we mentioned, the claims authentication manager, the one that looks at your claims collection and can check if your user belongs to a database, can add extra info to the system, and similar. At this point, we are already past which kind of a token we used, which kind of protocol we used. Here, we are just working with claims. We no longer have a token. And let's assume that we are happy with that. And so we give you back a collection of claims. And we raise another event. We validated it. Then at this point, we create a session. So here we are calling the session authentication module, but there is a twist. We are calling it as a class, not as an HTTP module. That's to say that this module also happens to be a C# class. It has methods. Here we call those methods because simply, since we are doing the same job that it would do, it does not make sense to write the code twice, right? So we are calling it in there. But here we are calling it as class, not as module. That's important. And at this point, what do we do in here? We want to create a session token. A session token is a representation of what we want to remember of our touch experience with the token. Typically, what you want to remember is the list of claims, and the expiration. But sometimes, instead, you want to remember the entire thing. Because if, for example, you want to reuse that token as is for obtaining another token and making calls on behalf of your user, then there you want to remember the entire thing. Or some other time, you just want to verify at this point that you had a certain claim. And from this moment on, you want to get rid of it. Because maybe very sensitive information, you want to minimize the risk that it will be lost. So here is the place where you actually change the session security token handler. Also, before I mentioned the load balancing, here is the place where you decide what to use for encrypting the cookie that you are sending back. So if you are doing a load balanced environment, you want to use a key that is available in all your nodes. So again, this is the place where you change it accordingly. And in doing so, you also need another class, which is the cookie writer, which eventually will show up. Yes. So at this point, we write the cookie, we take this result, and we actually put it in the principal. So finally, it's the place where we put what we just got from the token in the thread. And at this point, once you have it in the thread, it's done. We are fine. And it's also in the cookie, so that next time that it will come along, the session manager will be able to pick it up and rehydrate what we have now in memory. And then finally, we can celebrate by raising signed in. Hey, we are done. Again, this takes a few seconds, a few milliseconds. And then at the end, we just call the end request. Let's say that we send everything back to the pipe, and we send back the set cookie so that the cookie gets created on the client. So that wasn't too bad, right? Right? Yeah, I know it's hard. But here you have seen all the things that you needed to know for customizing this. And it's not just for ASP.NET. Like this flow is for ASP.NET, but the function of these various things hold also for WCF. So if you understand these, and even if you vaguely remember that, then you understand the core. Like everything else is a detail. This is the only thing you need to understand for WF. And actually, most of the people don't have to. Here I'm duplicating. So let's say that we just went back and we got, I would say, our cookie. So now we are doing the last 200 in which we finally want to get our page. So here we have a user which is sending the cookie. More of a pretzel, but yeah, I've been recently in Germany. So we get to the FAM, and are we carrying a W result? No, exactly, because at this point we are just doing a 200. We are carrying a cookie. So the FAM says, I don't care, moves along, and vroom, the request goes straight. And here we go to the SAM. At this point, who remembers what the SAM checks for? SAM stands for Session Authentication Manager, hint, hint. So what does it check for? Exactly. If I have another prize, it would be yours. But I don't. What we get here is exactly the SAM, which comes up and says, hey, look at that. There is something for me. And here, instead of animation, I'm just showing everything because it's just two things. What we are doing is reading the token. And for doing that, we need the cookie handler, which is the thing that actually does the physical read of a cookie. And it's separated because you may know things about your session that we don't. Like, for example, you may have like a compression algorithm, which is better for your data. So if you want, you change it. But this has no semantic. It's pure I/O for the bytes. The semantic instead is in this session security token handler. This is the place, if you customized it for load balancing, for example, where you retrieve the correct keys and you use them for decrypting, checking signatures, deserializing, doing whatever you need for doing the session. And once you're done with that, you celebrate by raising the event session security token received, if you need to do something about it, like, I don't know, refreshing caches and similar. We set the principal so that now it is inside the, like we rehydrate these inside your thread, and that's it. And we are happy. So we move forward. We get in here, we get in the post-authenticate request of a FAM. Who remembers what happens in here? This is tough. This is the place where we check if the principal is an iClaims principal. And what do we have now? Exactly, we have an iClaims principal. So again, move along, request goes straight. Next step, who remembers instead what happens here? Exactly the same, I was counting on that. So again, nothing to do, nothing to see, move along, sir. Great. And then here we have our good old UAM. We get in here, and this time we have in is authenticated true. So we are happy. But then, once we get in here, before we didn't get in there because we weren't authorized, so we blocked everything. We get in here, and the next step is we instantiate, if present, the class which handles authorization. At this point, we do all our checks, and if we are happy with that, finally, we can move things further, whatever else we have in here, and finally the claims get to the app. Long, eh? So this is where all the various players play their role. And that's it. Like from now on, those are the Lego blocks that you play with, and you can build whatever you want. So here are some common ways of doing these things. As we said, Claims Authentication Manager is one of the classic places where you do that. Here is where you do registration. If you want to see samples of that, just look at the Windows Mobile tool, the Windows Azure for Windows Phone 7 toolkit. And if you use the ACS route, we'll use exactly that. Like when you try to use a new token, we never saw you, we say, hey, you know what? We'd like to know about you. Do you want to register this account? And that's the place where we check if you were already registered, and if you weren't, we add you. So that's a good place to do that. And in fact, most of our examples with registration will do that. Then we can add stuff. Imagine that you are, I don't know, a big bookstore, and you accept identities coming from one big auction website. I'm not doing any names because LCA, which is our legal department, will come after me. And let's say that you accept identities coming from there, and from there you get interesting things like the shipping address, like the name of the guy, like, I don't know, even their credit score if you are very lucky. But what you don't get there is the last 10 books that they bought at your place, because you know that, they don't know that. So here, that would be the place where you say, ah, yeah, I recognize this guy, always comes here, reads very weird books. Here I have a recommendation for you. And that's the place where you would do it. And also for the sign up, same thing, that place where you put stuff in the database. The Claims Authorization Manager is the same. Here, the interesting thing is that with great power comes great responsibility. In this point, you can do whatever you want, literally, whatever you want. But the same can be said for Turing machines, and they are not exactly the most productive tool on the planet. So here, basically, what happens is that you have all the hooks for adding your logic, and you can do really interesting things, like age checks, dates, spending limits, structured data, whatever. You can write the policies in whatever format you like. You can keep them in a database. You can keep them in web config. You can do anything, but you have to do it yourself. That's to say that we don't give you any tools for doing that. So you can do fantastic things, but you've got to write. And if you want to see samples of that, download the Identity Training Kit, and there we show you how to use this stuff. We give you some ideas about how to use policies, but we don't have a UI that you can go there and play with. So be warned. Also, very often, you'll want to stick with roles just because if you don't need more, they are already integrated in ASP.NET. Session Security Token Handler, I already touched on that. You can play with sessions in very interesting ways. The redirected to identity provider is an important thing to look at. And I apologize for the fact that it's really on the bottom. Better? Basically, what we do in that event is exactly what I hinted before. You grab that thing simply when you want to tell something to your identity provider. So sometimes you contact that STS, but that STS is not the one that will authenticate the user. That STS can be a broker, which is going to forward the user further. So for example, if you use the access control service will not check your credentials. It will forward you to Google, Facebook, your Active Directory, or similar. So if when you are sending the request, you already know where you want the user to go. For example, I am an admin. I'm giving the link to the application to all my users. I want to embed my own identity provider so that when they get to ACS, they don't have to see the choice and maybe click on the wrong one. I want them to go straight in the right place. I want to embed that information in the URL, and I can. But then when I get it to the application, and the application forwards it to ACS, if I don't do something in the redirecting to identity provider, like reading this thing and putting it back in the message that I'm sending, then that information would be lost. So that's where I want to do that. Or let's say that in the request there is something which says, I want to use certificates for authenticating. The only way in which I can tell the STS that I have a preference for credentials is here. So again, that's a very useful method to know about. Thank you. Thank you. WCF. How many of you guys are WCF developers? Whoa, there's a lot of you. So how many of you guys know what is a service authorization manager? The silence is deafening. There is at least one. So this slide will be useful once you download it for a reference. Let's say that here there is the way in which we wedge ourselves in the WCF pipeline. We use a number of extensibility classes in there. The message that you need to get here, not the details of the classes, but we use their model, and then we completely override it. That's to say that WCF gave you a way of looking at claims before WF. Ignore that way. Use WF. You can use exactly the same stuff that I've shown for the ASP.NET case. Simply grab from the thread the iClaims principle and use that. Don't even try to look at the model of WCF. Also, WCF had a way of supporting custom tokens. But for supporting one new type of token, you needed to implement something like 11 custom classes. So it wasn't exactly like, I don't know what is your idea of fun, but even I spend a lot of time underwater with the dragons. I don't like that. Instead, then, WF gives you one single class, the security token handler, which governs everything. And in fact, here, again, you can ignore it for the most part. The important thing is that, as you can see here, the security token handler, which is already in the WF object model, is something which is used for facading the WCF underlying. So, long story short, don't use any of the classes that you would normally put within WCF. Wedge Windows Identity Foundation in its pipeline, and there are a couple of very simple ways of doing that. They are on the slides. And then from that moment on, use Claims Authorization for the Authentication Manager, Claims Authorization Manager, and you can reuse exactly the same across ASP.NET and WCF, so that's pretty handy. And I don't think I will inflict on you the custom OAuth scenario. So I'd say that since we have 1 extra minute, I'll probably stop here. And then if you have a few questions that you want to go on record, you can ask there. Otherwise, we can just spend some time here, and I can give you a headache about this. So thank you for your patience. You have been awesome.